Today, I'm going to talk about IntersectionObserver, a new API, and why a new HTML JavaScript API, and why it's time to start using it. But before I start, I'll just quickly say something about myself. So my name is Jonas. I am a Swedish guy who now live in Paris. I love open source web performance, tooling, React. I've written some, like Ilya said, some open source tools that work with critical CSS to make websites faster. In the past, I created a SaaS business on top of one of them, the business is called criticalcss.com. Now I work for an AI startup in France, in Paris, where I lead our front-end team. And Snips, this company, we use voice AI to basically make technology disappear. We have a platform where you can create voice assistants that can control smart speakers, they can control coffee machines, control anything you want, basically. So that's what I do daily. But today, we're going to talk about IntersectionObserver. So roughly, the outline of this talk is going to be, first I'm going to tell you what IntersectionObserver is about, why you need it, and what it is good for, but also what it's not so good for, and how you can use it today so that you can go home and make use of this on your websites or web apps or whatever it is that you are building. So what is IntersectionObserver? Can I get a raise of hands first? How many here have heard about the IntersectionObserver before this talk? Okay, a few. How many have used it at all? Okay, a few people. That's good. A good mix. So hopefully it's not a great mystery. The name is meant to be kind of descriptive. IntersectionObserver is about observing when elements on your website intersect, when they overlap. They could have kind of given it a better name. Like the most common use case for intersection observing is InView Monitoring. It's monitoring when things come into view on your website, onto the screen. But the reason it's not called InView Monitor or something like that is because that's the default behavior, but you can modify the route so that you no longer monitor whether something is in the view, but whether something is intersecting with something else. So you can use that for more custom use cases. But today I'm going to talk about InView Monitoring, but that's the most common use case for IntersectionObserver. So what do we use that for? We can use InView Monitoring with IntersectionObserver to do things like lazy loading content, to instead of loading all the images that you have on a long web page up front, you can load just a few of them and then progressively load more and more as the user scrolls down on the page. And you can use the same technique for loading in more content when you have an infinite scrolling list and these kind of use cases. You can use it for in-view tracking to report when certain content was seen by users. So if they ever scroll down to that video that you have on the last part of your web page. You can also use it for something like animation triggers to fade in content as they come in onto the screen like this. So we all know what I'm talking about. Hopefully I can play this. I couldn't. That's a bit of a... OK, you can see it. I can't. Yeah, so just fade in some content when it comes into view. You can do things like this. So a legit question here is, why do we need a new API for this? Because really, we've been doing these kind of things on the web for years. I've been doing them for years. There are certainly ways to do these things without IntersectionObserver. So why did we come up with this new API? Well, the thing is, without IntersectionObserver, if you want to write this kind of code yourself, you're very likely to end up with a little bit of code, more than you would like, and it starts to get a little bit complex quite quickly. And most of this resolves around performance issues, which was another big reason why IntersectionObserver was thought of. Because basically, what people generally do when they try to do InView monitoring is they start setting up scroll listeners. And this is what has been responsible mostly for why people think the web is slow, why we have things like websites that lag or have scroll jank when you try to scroll them down, and why people think things like that the web can never be as smooth and provide as good as an experience as native applications. So all of this comes from not having better support for things like InView monitoring, and this is why IntersectionObserver was thought of. But let me say something a little bit more in detail on why it's kind of complex and badly performing to do InView monitoring on your own without something like the IntersectionObserver API. So I already said briefly that if you listen to the scroll event by yourself, it's a little bit problematic. You can't just use it in a naive way. The scroll event fires continuously and quite repeatedly. It can fire several hundred times a second, and you have basically no control over how often it fires. It will vary depending on what browser you're in, what OS, what type of device. So if you use something like a scroll listener, you have to make sure you throttle it, and you have to know about throttling. If you want to determine whether something is in view, you probably use an API like getBoundingClientRectangle on DOM elements, because this gives you the relative view coordinates of an element relative to the viewport. This is what you want to use. But the problem is this method is too slow. It can take several hundred milliseconds every time you call it. So if you call it continuously every time the user scrolls on multiple elements at the same time, it's just going to take too much time. You can't really use something like this inside a scroll event listener. And finally, OK, so these are some problems. But obviously, you can work around, and you can start caching expensive DOM method calls. You can throttle your scroll handler. But if you, for example, start caching the expensive calls, you need to start handling the case where after you've cached the position of an element relative to the view, if you modify the page content, maybe you expand an accordion or something like that, the cached values are no longer relevant. And it just gets more and more complex. And it's totally possible to do. But most people on the web didn't do it well enough, basically. And it's not easy to do well enough. So IntersectionObserver makes it a lot more easy to do the right thing by default. So that's why it's here. So in contrast to what I talked about so far, let's look at what it looks like to do something like InView monitoring with the IntersectionObserver API. So we start by setting up an observer. Can everyone see the code, by the way? Even in the back, is it big enough? Or, yeah? OK, good. We start by setting up a new observer with the window.IntersectionObserver method call. The argument to this API is a callback function, which I called onIntersect, which we will look at next. And then at the bottom, we just call observe, observer.observe, with any DOM element that we can find on the page. And then in the callback function, we receive an array of entries. And we receive an array because we can observe multiple elements at the same time. Then we can loop through each of these entries. And the interesting line here is just entry.isIntersecting, which basically just tells us out of the box whether the element is in view, which basically this replaces all the code and all the hacks and all the workarounds we had to do before. This is all you need to do a simple InView monitoring with IntersectionObserver. So it's pretty neat. It's much better than before. The code is much cleaner. But it also avoids performance issues. And I'll say a little bit more about how it avoids performance issues. So IntersectionObserver basically comes with performance built in. It's built to be performant. It's built so that we avoid repeating the mistakes of the web accidentally becoming broken and really slow because of the way people use it. So it's hard to make this not work well, basically. So I said that something like getBoundingClientRectangle, which is what we would use to natively, on our own, figure out if something is in view or not. There's no need with IntersectionObserver to make any call like this. All the intersection checks are already handled by the browser, and then handled in an optimized way, so that you get static values, basically, that you can make use of. That is just fast. I also talked about the scroll event firing too often. You don't really have this problem with the IntersectionObserver API because the callback that you get, it doesn't fire continuously all the time. And it's also set up to internally make use of an API called requestIdleCallback. I don't know if you've heard about this API, but basically it's something when you call the requestIdleCallback with some work, it tells the browser that I want you to do this, but when you have some time, when you're not busy with too much going on with videos playing, the user scrolling too fast, it's never going to be called in a way that makes you lose frames and cause scroll jank. It can happen a little bit later if your browser is too busy for when it would have otherwise fired a callback. The callback can be delayed a little bit. Carry on. So it by itself avoids the performance issues, the type of performance issues we would get when we write this kind of code on our own. But it's worth noting here that I said the callback doesn't fire continuously, it doesn't fire exactly when the intersection happened. It fires when after the intersection has happened, when the browser has some time. But this has some implications for how we can use an API like this. And one usage area where people talked a little bit about the intersection observer and whether we can use it or not is for animations. Because some people were saying because the updates are delayed and we don't have any control over exactly when they fire, it might not be a good use case to use them for animations. So I would say, yes, if you need continuous updates, if you want to animate something to trace the scroll position, to keep on moving as you keep on scrolling, if you want to do something like parallax effects, you shouldn't use anything like the intersection observer API. It's not meant for this kind of use case, and it will not work well. If you just want to do a one-off start of fade-in animation of something that comes into view, and if you're OK with it happening a little bit delayed, possibly if the browser is busy, then it's fine to use it for something like enter and exit animation triggers. It's perfect for this use case. So I would say in general, make sure you test your use case, but you can use it for animations, absolutely. OK, let's see a little bit more what the intersection observer API looks like. I want to note that I'm not going to show you every single method and property you can get from the intersection observer API. I will tell you the most useful ones and what they're used for. And if you are really interested, there are a few more things you can look up on yourself, by yourself, or you can come and ask me afterwards. So the first example I gave you was how to do in-view detection via the entry that is intersecting. I need to do a little warning here that entry that is intersecting, unfortunately, isn't exactly what you kind of think it would be. It doesn't actually correspond to whether an entry is intersecting or not, whether it's in view or not. It corresponds to whether the element now intersects more or less than before, which for the most common use case, whether you just wanted to say whether something came into view or not, it will still be the same because before it was not. It will still have become more. But it's just, the name is a little bit misleading. But this was just because in the first version of the spec, the behavior was the former. But then they realized that it's more useful with the latter, and they kept the same name. So that's the way it is. It's fine. There's another way to do in-view detection with intersection observer, which you see a lot if you look at blogs and what people talk about with intersection observer. This is pretty much the same example as before. I don't know if I have a pointer. I don't think I do. OK. It's the same example as before. But instead of checking is intersecting, I'm checking entry.intersection ratio and checking that it's greater than 0. And what does I have one more slide on this. What does the intersection ratio correspond to? So intersection ratio is basically the area that's intersecting out of the total area that we're viewing or monitoring. So by default, with the default behavior, it's the area that's in view, how much the element is now in view. So visually, with the picture I took from Google's developer blog, if an element is completely outside of the view, which is the default behavior, the intersection ratio is 0. If it's completely in view, intersection ratio is 100%, and then anything in between. So obviously, we can also use this for determining whether something is in view or not. But there's one more warning here I need to give on when you use this particular method for determining whether something's in view. You need to also specify a threshold, which can go into the config, which the intersection observer call takes as a second parameter. And what is the threshold? Threshold is an array of intersection ratio values. So the intersection ratio that I just showed you, you can specify a bunch of them. So these are percentages. So 0.01 means 1% in view. 0 means 0% in view. You can specify a bunch of them. And when each of them are crossed, when the element becomes more or less visible than this, you will get the callback that I've specified, the onIntersect callback. So in this example, let's just look at the JavaScript. It's the most interesting part. I'm taking a bunch of DOM elements from the DOM. I'm selecting them all. Here I'm just converting the node list that we get by default into an array because we want to call for each. Don't worry too much about that. It's just the way the DOM APIs work. Then we call intersection observer 3 times. 1 time without any custom config, with nothing. 1 time with a threshold array with 3 values, 0.
Possible to make that bigger?
That can probably be made bigger. That's a good point. Is that better?
Yeah.
The second element will have 3 values, 0, 50%, and 1, and the third one will have a lot of values, basically. And the only thing I'm doing in the intersect is I'm setting an inner HTML. I'm changing the text inside a label to be the intersection ratio value converted into a percentage. So let me show you what I mean. So with the default behavior threshold 1, a threshold of 0, we're going to get one update when we cross into this element. It's going to update once and no more. If we add more threshold values, so 0, is this too small as well? 0, 50%, and 1. Ooh, now I get a really small view area. Let's stay with this. Then we get 3 updates. One at the beginning, one when we cross 50%, and one when we leave at 100%. And we can't see that anymore. It's a bit of a shame. Anyway, and then if you use this, you would only use this for demo purposes. But if you specify one value per percentage point between 0 and 100%, you get continuous updates all the time, as you expect. So this is what thresholds do. This is what they're used for. One thing that is interesting to note here is the delayed and asynchronous nature of this API that I talked about before. Even though you specified 0 as the value here, you can get a much higher value because by the time the browser had time to execute the work you scheduled, you have already passed the threshold by a bit of a margin. So this is important to know for how this works. The other thing that I think is important to note is that even though you specified 0 and the behavior is supposed to be when we cross that threshold, so when the intersection ratio is greater than 0, you can get exactly 0. So I was saying we have to specify a threshold greater than 0. And this is because if we specify 0, we can get an onIntersect update that actually is supposed to mean that the element is now in view, but we can't distinguish it with any intersection ratio check from an update that said element is not in view, because 0 is the lowest possible value you can get. So it's just, yeah, something you need to be aware of. If you use this method, you have to specify a higher threshold. I got burnt by this. I didn't realize you had to also use a threshold in this case, so something to be aware of. I've gotten some questions about with the IntersectionObserver API about thresholds and callbacks, so I want to say a little bit about that. As you maybe already intuited from the demo I gave, when I specified 100 values in the last threshold array, so that it was supposed to update with each percentage point of the element that I crossed, you don't actually get one callback per threshold, per intersection ratio threshold in the threshold array. Because of the async nature of this API and because it's also kind of throttled, if too many of your callbacks, if you have a lot of thresholds, fire at the same, close to each other in time, you will just get the latest update, basically. So just note that it's not so important for most use cases, but you won't get updates corresponding to each single intersection ratio value. More interesting is, okay, also that on intersect, this callback that you get when you set up when the element is crossed, when the intersection ratio changes, it also fires as soon as you call the initial observer.observe. So when you first do the first setup, you will get one callback, which is useful to know. This is what I already said because the order changed. Sorry about that. This is what's also interesting to know because I wasn't really expecting this. So what happens if the browser is really, really busy? If your user scrolls really, really fast, you have a lot going on, and you're doing intersection observing on like a really thin element that passes by on the screen for 10 milliseconds. It's actually possible that you don't get any callbacks at all. I'm not sure if this is a bug or not. In Chrome, for example, this doesn't seem to happen much at all. Like, it's really hard to reproduce this. But in Firefox, in my tests, you can get this to happen quite reliably. It's just another point to note about this API, that this API is not about getting exact data. It's about getting a performant InView monitoring. The trade-offs are in order for it to be performant rather than to be super accurate. But for most use cases, what we use IntersectionObserver for, this should not really be a problem. It's just something worth noting. OK, a few more things a little bit quickly. What I've said so far will not allow you to determine what direction something is coming into view from. We can only tell whether it's going into view or out of view. But remember the bounding client rectangle that I said we had an expensive get bounding client rectangle method we could call before, but we couldn't call it because it was too slow. IntersectionObserver provides us a static read value of this exact same kind that comes on each entry that you get in the callback. So you get this value for free. And using this value, which tells you the relative position, together with the is intersecting, you can tell whether something is coming into view or coming out of view, and whether it's coming in from the bottom or left or right or whatever. You can use it to determine their direction, which is useful. Something else about the observer, another useful thing in the API. I already covered that you can reuse the observer. You can call observer.observe multiple times with multiple DOM elements. It's also possible to use multiple observers at the same time if you need to pass in different configurations, which is what I did in the demo when I passed different thresholds for each of the elements, just to show off what the thresholds does. It's probably more common to actually call observe multiple times on the same elements, but you can do both. To clean up our intersection observers after we've done with them, you can call observer.unobserve inside the callback. So in this example, let's say you're lazy loading some images. Once they come into view, you do some lazy load image logic. Then you stop observing them so the browser can free up that space and stop consuming resources for this. And you call unobserve with enter.target, which is the DOM element that we observed to begin with. So this will be your link or your div or whatever it is you passed in. And you can obviously use enter.target. Well, obviously, OK. You can also use enter.target for other things. But unobserving is one of the things you can use it for. Further to clean up, you can also call disconnect on the observer itself. This can be very useful. For example, if you have a single page application, you set up a lot of observing, and now you're leaving page to another page, and you just want to clean everything up, then you call observer.disconnect, and it just unobserves all the elements for you and just cleans everything up. So it's useful for that. The final thing I think that I wanted to say from the API that is quite useful is there's another option on the config for the intersection observer when we initiate it, which is called root margin, which changes the dimensions that are used for the root, so by default the viewport, when we consider whether something is intersecting or not. And I'll show you what I mean by that. But first I just want to say root margin is a CSS margin. It's pixels, so it's top right, bottom left, just as we're used to. It can be pixels or percentages. No other values are supported currently, but these are the ones that can be used. And I had a quick, and yes, you can use negative margins, which is also very useful. So we have one more demo. It's very quick. In this onIntersect callback, I'm just adding a class if it's in view and removing the class if it's the elements out of view. And with the class, I'm only changing the background color, so it's kind of simple. It's kind of well, never mind. you judge what it is. So the interesting point here is I'm setting a root margin of negative 200 pixels. And just to show off that you would expect that as soon as the elements come into view, they will be green. But because I set a negative root margin of 200 pixels, the change happens 200 pixels later. That's what root margin does. If I set it to a positive value, you can't really see this because then the change will have happened when the element is outside of screen. So that's not so easy to demo. But I will say something about that. Just the most common use case, though, for root margin, I would say, is to use a positive margin to start some lazy loading logic, not just exactly when the element is about to enter the screen, but maybe one screen ahead of time, something like that. You do it a little bit earlier. You could use negative margins for certain things, but let's not go into that because I haven't thought of a good use case for a negative margin, actually. OK, so this API is pretty cool. But what about support? Can we actually use it today? This is something you always need to know when you're working with new web APIs. Generally, the support is quite good nowadays. It's already supported in the latest versions of Edge, Firefox, and Chrome, and Opera. But unfortunately, it's not yet supported in Safari, although they're working on it. But this means that you need a support strategy. But it's quite easy. You can do it with some work. I have two different support strategies to recommend. And so you can use progressive enhancements and just do something like have a baseline that works even when IntersectionObserver is not available. So instead of lazy loading the images, you just load them in some traditional way. And you start the lazy loading if you have IntersectionObserver available. But I would actually recommend to use the polyfill for IntersectionObserver, because the polyfill, the ones that are available, they come in at about 1 kilobyte gzipped. And if you use a polyfill service like this one this is quite nice. They only return the polyfill, the code that's needed, and only execute it for browsers that actually need it. So you don't incur any real penalty if you use it in a modern browser. One thing really quickly to note, the polyfill obviously doesn't work exactly the same as the real code because it doesn't use the same APIs. It's as performant as the real IntersectionObserver, but the trade-off they made to make it as performant is that unlike the real IntersectionObserver API, the polyfill by default does not, for example, react to if you change dimensions of an element inside a CSS hover or transform or something like that. It doesn't update if you resize a text area on your page. So by default, it doesn't do anything like that. You probably won't need it for your use case, but the polyfill can be configured to support anything you need it to do. It's just not doing that by default for performance reasons. So the final thing I'm going to talk about today is how we use IntersectionObserver at Snips, the company I work at. So we use React. How many people use React in this room? Quite a few. Yeah, nowadays it's very popular. So I'll say something about how we use it with React. So we use React because React uses components, and React focuses on declarative code, which we love. And I'll say something about declarative code so everyone knows what I'm talking about. Declarative is like placing an order, like saying, I want a Big Mac, and I don't care how you make it. I'm just specifying the result. Whereas imperative is a little bit more like a recipe. It's like, OK, cut the cucumber, rinse the salad. Step by step, you have to kind of read the whole recipe to know what you're going to get in the end. And where I'm going with this is DOM manipulation is kind of imperative. It's like we create an observer, we observe some elements, we specify step by step what we're going to do. When we receive an update. So we don't want to sprinkle this kind of code everywhere in our code base if we have use cases for IntersectionObserver commonly, which we do. So we create a React component to handle this, of course. So we have an element that we want to animate in. We just wrap it in our own InView monitor, and we say, when it comes into view, we add a class name, like animate it and fade it in. So with this, you can use reveal animations like the animation I showed in the beginning. You can pass child props, so you can start playing a video as soon as the elements come into view. And this is really handy, not just to start auto-playing videos, but also to stop them when they go out of view. So you stop using that GPU, and you stop killing mobile battery, which you can drain really fast if you have a lot of videos that just keep on playing even after you've scrolled past them. You can use this for more things. You can do things like tracking when elements come into view, which is something I mentioned before. And with the custom callback function, you can do anything you want. It's just a wrapper on top of IntersectionObserver. So we call this library React InView Monitor. It's declarative, easy to use. It uses IntersectionObserver under the hood, and it's open source. So if you want to use it, you can do so. You can find it here. In summary about IntersectionObserver is here. You can use it today. You can use it with this polyfill. This is what we do. It works now. You don't have to wait. For in-view detection, it is an easier and much better option than what we've had before, manually declaring scroll event listeners and writing all that code for yourself. So closing, we are also hiring at Snips. If you're open to an amazing adventure, I worked in London before. I took a journey to Paris where I work now, and I work in an amazing company, an AI company, which is the greatest company I've ever worked in. We are also hiring. We're hiring specifically for the front end. So if you're interested, check us out or come and talk to me. And that's all. Thank you.